There's one thing that's made me think a lot for many years in a row. One thing that most people don't bother to notice because our intuition, that very natural feeling of understanding the world, usually works quite well in everyday life. But the problem is this. When you take that intuition outside the scope of the dinner table, the road in front of your house, or the drive to work, and apply it to the scale of the universe, it collapses instantly. And I'm telling you honestly, it doesn't just collapse, it gets mercilessly crushed by the universe. Because when you really look at physics, when you examine how time works at high speeds, when you calculate the distances between stars, when you notice the strange limits of light, you start asking a very uncomfortable question. Why do we think our intuition can help us understand the universe? When you live on Earth, a tiny planet with distances measurable in minutes or hours, intuition works fine. But when you step out into space, into a place where every scale is far beyond human experience, intuition immediately blows a fuse. It doesn't know how to handle the fact that time can flow faster or slower depending on the observer. It doesn't know how to imagine a distance so vast that light, the fastest thing we know, still takes years to cross it. And it certainly doesn't know how to deal with the reality that to accelerate an object to near the speed of light, you have to supply it with so much energy that no intuitive system was ever designed to comprehend it. Think about that. If you've never left your city, you might believe that every road in the world is roughly the same length as the trip from your house to the grocery store. But you only need one cross-continental flight to realize your intuition got it completely wrong. Now magnify that error by thousands, millions of times. That's the gap between our intuition and the reality of the universe. Before you think I'm trying to make everything seem mysterious or incomprehensible, let me be clear. I am a physicist. I believe in evidence, in mathematics. I believe in truth even when that truth doesn't fit our familiar intuition. And that's exactly why this issue fascinates me. Because when you do the math, when you look at the laws of physics, when you try to use your intuition to explain the universe, you find that intuition is no longer a reliable tool. And if we're not willing to break it, to set it aside like a ruler that's being used in the wrong place, we'll never understand why aliens can't come here. Think about that. When intuition has been so mercilessly strangled by the universe, you and I are forced to start everything over from zero. If intuition doesn't help, we have to replace it with something else. Numbers, distances, the things nature has written across the universe over the past 13.8 billion years. Because before we can ask, why haven't aliens come here yet? We have to confront a far more important question. How big is the universe really? We often say that as if it's just casual small talk, like nice weather today, huh? But the truth is, we don't actually grasp the number we're saying. We weren't born to understand it. None of us has neural wiring designed to process tens of thousands of light years, let alone millions or billions. But if we want to talk seriously about the possibility of alien travel, we have to cross this threshold first. So, let's set intuition aside for a moment and climb with me up the cosmic scale ladder. Each step making your brain feel a little smaller. Start from our cozy little home. Earth, diameter about 12,742 kilometers. Sounds big, but still within the imaginable range. You could circle it in a day and a half on a cruising airplane. Everything still makes sense. Now, let's zoom out one more level. The solar system, distance from Earth to the Sun, is 149.6 million kilometers. Light takes 8 minutes and 20 seconds to get there. You can still measure it in seconds. Do the mental math and intuition still tries to hang on. But the moment we move to the nearest star, Proxima Centauri, intuition immediately lets go. Proxima Centauri is 4.24 light years away, meaning light, the fastest thing nature allows, still needs more than 4 years to travel from there to here. Try sending NASA's Parker Solar Probe, the fastest spacecraft we've ever launched, reaching 692,000 kilometers per hour in 2018 to get there. Result, about 6,600 years of travel. 6,600 years. And that's just the nearest star. Now zoom out a bit more. The Milky Way, the galaxy that contains our home. It's about 100,000 light years across and contains 200 to 400 billion stars. If you travel from one side to the other at Parker Solar Probe speed, you need hundreds of millions of years, longer than the entire history of multicellular animals on Earth. But we're not done yet, because above the Milky Way is the local group of galaxies. Above the local group is the Laniakea supercluster with over 100,000 galaxies. And above Laniakea is a cosmic web of structures stretching across the entire universe that no amount of chalk, blackboards, or paper could ever fully draw. This is the non-intuitive nature of the universe. You can't draw it. You can't imagine it. You can't feel it. The only thing you can do is accept it. And if you don't truly grasp this scale, every question about aliens goes off track. Before you ask, why don't they come here? Ask yourself, where are they in a map spanning tens of billions of light years? If we can answer that, the first verdict every civilization must face becomes crystal clear. Distance. So when we start talking about whether aliens could visit Earth, the first verdict any civilization faces is distance. And I don't mean far, like you have to drive a few hours to visit relatives in the next state. No, not at all. I mean distances that life itself, no matter how evolved, has no way to overcome. Cosmic distance isn't just large. It's beyond the evolutionary capability of living beings. Let's go back to the most familiar example, Proxima Centauri, the closest star to our sun. Its distance is 4.24 light years. But that number doesn't convey the true essence of the problem. You have to feel it. So try this. If the solar system were a Major League Baseball field about 120 meters long, then Proxima Centauri wouldn't be at the stadium gate. It wouldn't be in the parking lot. It wouldn't even be in the city. It would be in another state. And in that analogy, you're asking, why don't people just run from the ball field to the next state to say hi? Distance doesn't allow it. It's not merely inconvenient. It's impossible. Now, back to reality and the real numbers. Parker Solar Probe, the fastest human-made object ever launched, hitting 692,000 kilometers per hour in 2018, if sent straight to Proxima Centauri, would take about 6,600 years to arrive. So that's a one-way trip longer than the entire history of human civilization. By the time the probe gets there, our language will likely have changed completely. National borders will be unrecognizable, and the civilization that sent it may have vanished. And the irony is that's the nearest star. That's our close neighbor on the cosmic map. From a physics perspective, the first step of any interstellar journey is already an unbridgeable abyss. And things get worse when you realize the speed of light isn't a goal to conquer. It's the absolute limit nature imposes on anything with mass. You can't exceed it. You can't cheat it. And you certainly can't ignore it. When you accelerate an object to near light speed, the required energy rises exponentially and its relativistic mass increases to the point where you can't supply enough energy to break through. Science fiction often talks about warp engines or hyperspace jumps, but physics doesn't write scripts to Hollywood's wishes. Nature doesn't care about our convenience. It operates by its own rules. So even if an alien civilization is thousands of years more advanced than us, they still face the exact same limits. They're blocked by the speed of light too. And if they want to shorten travel time, they'll have to supply unimaginable amounts of energy and then deal with all the other problems. Radiation, cosmic dust collisions, spacecraft structure, and most importantly, their own lifespan. But suppose they still try. And suppose they're not 4 light years away, but 4,000 light years away, a perfectly ordinary distance inside the Milky Way. Light takes 4,000 years to cross that gap. A radio signal saying hello, sent before Alexander the Great was born, would only just reach us today. And if they're 20,000 light years away, then every idea of meeting, visiting, or chatting becomes impossible. Not because they don't want to, but because distance has canceled every possibility of encounter from the start. And remember, we're still talking about distances inside the Milky Way. If they live in another galaxy like Andromeda, 2.54 million light years away, then every notion of travel or visiting becomes meaningless. 2.54 million light years means light, the maximum speed the universe allows, must travel continuously for 2.54 million years to arrive. No civilization lives long enough to witness that journey, let alone carry it out. All of this leads to a simple but powerful conclusion. Distance alone has already slammed the door shut. Before we even talk about energy, time, biology, or information, distance stands there as an absolute wall, a verdict every civilization must accept. The universe isn't designed for civilizations to meet each other. Stars aren't placed conveniently close for popping over. There are no intergalactic highways, no shortcuts. You can't send a ship across that distance, and neither can they. Distance is the first verdict, and it's strong enough to make a visit to Earth from any civilization in the universe impossible from the very moment the idea is conceived. And this is where we face another truth of the universe, one that many people hope can be worked around. But physics isn't traffic law. You can't get an exception. If distance is the first verdict, then the second, and perhaps the cruelest, is the speed of light. And I need to make this clear right away. The speed of light isn't a goal to strive for, a number to brag about, or a milestone you can overcome with enough persistence. It's a foundational law of the universe. A law with no exceptions, no shortcuts, no priority mechanism, and certainly no concern whether you're a low-level civilization or a high-level one with chemical engines or antimatter reactors. Let's start with something that seems simple. You push an object to make it go faster. We do this every day. You pedal harder on a bike. It speeds up. You floor the gas in a car. It accelerates. And with that intuition, you might think that if you want a spacecraft to go from 10 kilometers per second to 20 kilometers per second, then to 50 kilometers per second, then to 100 kilometers per second, you just need to push harder. But that's Earth intuition. And as I've said, intuition has no power at cosmic scales. The problem is this. The faster you push an object, the heavier it becomes. Not heavier like stepping on a scale after a big meal and seeing a few extra pounds, but heavier in the physics sense. Relativistic mass increases. Faster, heavier. Heavier needs more energy to keep accelerating. And as you approach the speed of light, the energy curve doesn't rise linearly like you might imagine with a pencil stroke. It rises vertically. A tiny step in speed requires enormous energy. Hundreds, then thousands, then millions of times more than the previous step. The harder you push, the more it refuses to go faster, because the energy you're pouring in is converting into its mass. And if you try to reach the speed of light, physics demands you supply infinite energy. Not a lot, not more than a galaxy can provide. Infinite, a number no star, no supercluster, no energy source in the universe can supply. It doesn't matter if you're from Earth or an alien from a Type 3 civilization encompassing an entire galaxy. The speed of light is the final wall. You can get very close, extremely close, but you'll never cross it. And once we understand this, many questions become meaningless. For example, why don't they just come faster? Because they can't. Why not build a stronger, more advanced engine? Because the stronger it is, the more relativistic mass the ship gains, and you're stuck in the infinite energy equation again. Why not use antimatter or black hole energy? Fine, you can dream about those technologies, but no matter what you use, you're still pumping energy into a massive object, and the result is always the speed of light refuses to let you pass. That's not a technical limitation. That's not a matter of engines not being powerful enough. It's the fundamental structure of space-time written into the universe from the moment of the Big Bang, more than 13.8 billion years ago. And to help you picture it better, try a familiar image. You're pushing a car down the road. At first, it's easy. You push, it moves. But then you hit an uphill slope. You push harder, it slows down. Near the top of the hill, no matter how hard you try, your speed increase is almost zero. Now imagine that hill gets exponentially steeper. And the top of the hill is the speed of light. You could push your whole life and never get over it. Effort rises to infinity. Result rises almost negligibly. And the most important thing is no one, no civilization, no intelligence, no matter how smart, can rewrite that law. There's no negotiating with the universe. No one is allowed to exceed the speed of light. And this is precisely why all interstellar travel is strangled at the root. When distances are already so vast, thousands, tens of thousands of light years, and the maximum speed any massive object can achieve is always below the speed of light. The time required to travel from point A to point B always far exceeds the lifespan of living beings, or even the lifespan of the entire civilization that sent the ship. You can shorten distances in your imagination. You can erase the inconvenience with sci-fi episodes, but in the real universe governed by real laws, that doesn't happen. The speed of light is a giant do not cross sign hanging across the cosmos, bright, proud, and uncompromising. And the interesting part, or perhaps a bit disappointing, is that any civilization must play by this rule. No exceptions. No cosmic master gets a special pass. No metaphysical technology lets you jump over this wall. Once we truly understand this, the picture of alien travel becomes very clear. They don't come here not because they don't want to, but because the universe locked the door the moment it was born. And once we accept that the speed of light is an absolute wall, the next natural thought for many people is okay. If we can't go through it, why not go around? That's where concepts like warp drive and wormholes enter our imagination. Hollywood loves them. Sci-fi novels love them. And even some scientific papers occasionally mention them to spark curiosity. But let's talk straight and seriously in the style of real physics. These are not shortcuts. They are dreams without enough energy to exist. Let's start with warp drive. In 1994, physicist Miguel Alcubierre proposed an interesting idea based on Einstein's general relativity. Instead of accelerating the ship to near light speed, you could contract space in front of the ship and expand it behind, creating a bubble that moves through space, while the ship inside remains stationary relative to its local space-time. Sounds brilliant, right? But there's a problem. To make this work, you need exotic matter with negative energy density. And we've never observed such matter in nature. We don't know if it exists. We don't know how to create it. And even if it did exist, the amount required would be astronomical, possibly equivalent to the mass energy of entire planets or stars. That's not engineering. That's fantasy dressed in equation.